Okay, so we're going to be talking about how do you show or, determine if you're given a shape with certain coordinates or factors, how do you show what shape it is? Okay, we're not really doing proofs, but we kind of are. Okay, we are talking about how would you know, how would you document it numerically as to what's going on. Pardon my voice. And so I think the first thing I want to talk about would be, if you've got four sides, of course we call it a quadrilateral. Okay, can't say that. Quadrilateral. And so then if you want to say, hey, is it a parallelogram? Well, you could do any of these five things to say, hey, it's a parallelogram. And so I like how this is laid out. And one way, the definition of a parallelogram is, hey, both pairs of opposite sides are parallel to each other. So you could find the slopes of both opposing sides, okay, on each direction and show, hey, they're parallel because the slopes are equal. You could talk about both pairs of opposite sides are congruent. Again, that normally requires the distance formula, and you have to do that with four different sides. So that's four things to do. You talk about both opposite angles are congruent. Again, measuring angles on a graph, not easy to do. Diagonals bisect each other. This is going to be the one that we mostly do. Why? Okay, when you have a parallelogram and when they bisect each other, they meet where? In the middle, at the midpoint. So if you find the midpoint along each diagonal, and if they coincide, then you know you have a parallelogram. So that's the easiest. Find the midpoint between, say, A and C, and then also B versus D, depending on your shape, B versus D. Okay, there you go. And if you find the midpoint, remember, add the x's, divide by 2, add the y's, divide by 2, and you find it between A and C and then B and D, then if those are the same point, if they meet in the middle, well, then they have a common midpoint between where they get bisected, then you know you have a parallelogram. So that's the primary way that I would say, if you're given a graph, the fastest way to show, hey, you have a parallelogram here. Okay, if you don't have a parallelogram, you should check to see individually, are any two sides parallel? Because you might have a trapezoid. And if two of the four sides are parallel, then you have to check to see, are the non-parallel sides congruent, to see if it's not just a trapezoid, but an isosceles trapezoid. So that would be where you would go if it's not a parallelogram. Okay. The next thing I would say is, once you're at the parallelogram world, okay, then you have basically two more tests to do. Okay, so let's look at what those two tests would be. You need to check to see, is your parallelogram actually a rhombus? And there are three ways to test it, okay? Because there's three main facts about rhombuses, okay? Their diagonals meet at a right angle. The diagonals, one pair of consecutive sides are congruent. Again, that requires the distance formula. That's not that hard to do. Diagonals are perpendicular, and then also the diagonals bisect the opposite angles. Well, the truth is, hello, Kitty, honey. Diagonals bisecting angles is very hard to show on a graph. And so I think the easiest thing numerically to do would be the second one. Can you show me that the diagonals are perpendicular? So if you find the slopes of the diagonals, and if they're opposite reciprocals, then you know you have a rhombus. Okay, so that's kind of cute. A rhombus is basically a parallelogram with all four sides congruent, and the diagonals meet at a right angle. And yes, each angle gets bisected by the respective diagonal that chops it in half. So the easiest way to do is find the slopes of each diagonal and then see if they're opposite reciprocals of each other. So that would show if it's a rhombus. The next thing I would suggest that you do would be, you want to see if it's a rectangle. And there are several ideas for a rectangle, but if you have a graph, the fastest way to do it is, again, focus on the diagonals. Are the diagonals congruent to each other? So you have to find the length of each diagonal and see, are the diagonals congruent to each other? So remember, if you've got a rectangle, this length equals that length there, okay? If you have a rhombus, these diagonals meet at 90 degrees. Okay, so again, it has at least one right angle. Again, you could calculate the slope of each side and see if they meet at right angles. That would be awesome. Okay. Or to see if there's just at least one right angle. If it's a parallelogram and it has a right angle, then you know it's going to be a rectangle. Now, here's the deal. If you have a parallelogram who is both a rhombus and a rectangle, okay, it's going to be a square. Okay, so that's a little hard there. I don't know why it has a heart. I didn't make it. Okay, so the main test we're going to do would be as follows. Find the midpoints of each diagonal, see if they meet at this middle. If it's so, it's a parallelogram. Find if the diagonals are perpendicular, find their slopes of the diagonals and see if they're opposite reciprocals. If so, it's a rhombus. Find the length of each diagonal, see if they're congruent. If so, it's a rectangle. If it's both a rhombus, a rectangle, and a parallelogram, then it's going to be a square. Okay, so if it's yes to all three things. If not, then you'll have to say, okay, what does that mean it is? Maybe it's just a parallelogram. Maybe it's a rhombus, and maybe it's just a rectangle. Okay, but if it's both a rhombus and a rectangle, if yes to all three things, it will be a square. Okay, so let's keep that in mind as we are doing our notes for today. Okay, and I would say refer to that. I'll hand out that sheet in class. Okay, so let's talk about all these shapes. So if you have a rhombus, what is meant by it? Okay, and so let me find this. If you've got a rhombus, the definition is that it's a quadrilateral that has four congruent sides. Okay, and so the typical rhombus looks like something like this. It's a parallelogram with all four sides congruent. Now, technically, you could call this a rhombus if all four sides, but the better name for this would be a square. Okay, is it a rhombus? Yes, but the best name for it is a square. Okay, so if all four sides are congruent, in a parallelogram with four congruent sides, it's going to be a rhombus. Okay, the next thing is the theorems that go with it, who will be, you could prove them, but we're not going to take the time. If you have a rhombus, then of course it's a parallelogram. All rhombuses are parallelograms. So they have all the character qualities of parallelograms. Refer to your first day of notes. If you have a rhombus, then the diagonals are perpendicular to each other. Okay, so that means if you have a rhombus where all four sides are congruent, that means the diagonals would meet at a 90-degree angle. Okay, and that's true of the square as well, because the square is considered a rhombus. Okay, so all four sides congruent means it's a rhombus. And then if you have a rhombus, then each diagonal bisects the opposite angles. What do you mean, woman? I'll show you. Okay, that means that each diagonal chops in half the angle that it meets. So this is angle C. That means these two pieces are congruent. That means these two also are congruent to the ones over there. Down here, this one matches this one, and then they also match these top two. Okay, now you're like, well, how is that special? Well, think about this. If you just had a rectangle, are those two angles in angle A's and B's corner, are those actually going to be bisected? And the answer is of course not. Think about this. This angle here is across from a short side. This angle right here, okay, is across from a longer side. Okay, so therefore, those two angles are not going to be congruent. Okay, this one right here, alternate interior angles will be congruent. Okay, so like this one up here will match this one down here. That's true. Okay, because they're going to be congruent triangles. But the angles don't get bisected in a rectangle. Okay, only in a rhombus and actually only in a square. Okay, because those are both considered rhombuses. Okay, so a rhombi, I couldn't be certain about that. So in a rhombus and also in a square as well, in a rhombus, these three factors are going to be true. It's it includes all the parallelogram attributes. The diagonals are perpendicular to each other, and then also each diagonal bisects the opposite angles. Okay. So angle C gets bisected by the diagonal. Angle A gets bisected by the diagonal. So each of those little pieces of A and C are congruent to each other. And then B and D both get bisected by that diagonal that goes vertically. Okay, so it's kind of cute. Now, let's think about working backwards. Okay, if you have, how do you show that you have a rhombus? If the diagonals are perpendicular, then you have a rhombus. I should use a highlighter. Okay, here we go. If the diagonals are perpendicular, then you have a rhombus. If the diagonals bisect opposite angles, then you have a rhombus. If consecutive sides are congruent, then the parallelogram. Okay, so if you've got a parallelogram with consecutive sides congruent, then it's a rhombus. Okay. And then what else do we have here? If your quadrilateral is both a rectangle and a rhombus, then it is going to be a square. So let's go over to our diagram over on the side, okay? Because remember that the first thing we've got here. Okay, so if you've got a parallelogram, okay, and you notice that one of these three things is true, then you can say you have a rhombus. The easiest one, if you have a graph, okay, with ordered pairs, is to show that the diagonals are perpendicular by finding their slopes and see if they're opposite reciprocals. Okay. You know the diagonals bisect opposite angles. Remember, these two angles are congruent, and so are these two. And then the top ones each match each other, and the bottom ones each match each other as well. And then one pair of consecutive sides are congruent. Again, you could use a distance formula and show that two consecutive sides are congruent. So it just depends on, if you've got a parallelogram, how do you want to show or check to see if is it also a rhombus as well? Okay. And so those are some factors. And then let me see if I can get back to our notes. Here we go. So if you've got a square, okay, what's the definition of a square? Well, the definition of a square is it has 4 right angles and 4 congruent sides. Okay, which makes sense. Okay, 4 right angles and 4 congruent sides. Okay, so what was it, a rhombus again? It's a parallelogram who has 4 congruent sides. Okay, or basically a quadrilateral with 4 congruent sides. Okay. And so let's do some numerical examples with what we've learned. So find the missing angle measures for these things right here. So if FGI is 65 degrees, that's down here. Well, that means if this is a rhombus, you know the diagonals meet at a right angle. And the angles, like the big angles at the corners of the figure, get bisected by the diagonal. So this is going to be 65 as well. And then this will be 65, and this is 65. And then over here, okay, let's think about it. If this is 90, well, then if you use the triangle sum theorem, 90 minus 65 from 180, this angle right here has to be 25 degrees. Okay, so I just did this triangle here and said, let's do the triangle sum theorem. Remember, the two acute angles of a triangle have to be 90 as well. So if you do 90 minus 65, you get 25. So this one will also be 25. Over here is 25, and here over here is 25. So not too shabby, okay? The diagonals meet at a right angle, and the opposite angles get bisected. Again, that's not true in regular parallelograms. I mean, I don't mean to say the word regular, but plain old parallelograms or rectangles, the angles are not bisected by the diagonals. But in squares and in rhombuses, yes, they are. Okay, so given a square, this right here, find the angle measures. Well, I don't know any of them. Well, yes, we do. Okay, first of all, we know this is 90, and the diagonals bisect each of those angles. Well, that means that each of these guys is going to be 45 degrees. And this one right here in the middle is going to be 90. Okay, so that's good to know what we're working with. Okay, and then let's look at side 2. Excuse me. Now here's one that says, hey, I spy some ordered pairs, okay? And you could take out some graph paper and actually plot these points to get a better look at like what is actually going on here, you know, because the truth is they say A, B, C, D, and all you really know is that A and C are diagonals and B to D would be the other diagonal. You don't really know like proportion or like location and like, you know, what would it actually be? So if you want to look at it and be like, okay, if you go to 1, 2, and then you go to -2, -1, and you go to 1, -4, and then you go to 4, -1, you'll see a better picture of this. Again, I'm not really using graph paper, so in my opinion, it looks kind of like a squarish rectangle, but I guess we'll have to do some math to show it, even if it looks like something, okay? Saying, oh yeah, it looks like it on your answer is not okay, all right? So what we want to do would be to look at our chart and say, okay, what would be our important steps here? Okay, so if you want to show, okay, do we have a parallelogram? The easiest way with points is to say, do the diagonals bisect each other? Can you find their midpoints and see if they have a common midpoint where the two diagonals bisect each other? Okay, so that's the fastest way to show, hey, do I have a parallelogram? Okay. You could find the slope of all four sides and see if opposite sides are parallel. That is absolutely a case, but you have to find four things. Okay. But that technically, no, that absolutely would work. Unless I tell you directly how to do it, you just have to say, is it a parallelogram? Yes or no. So you could use any of those factors that make sense. Measuring the angles probably doesn't make sense. Okay. So find the midpoint of the diagonal. So the diagonal would be from A to C, that'd be one diagonal. And then the other one would be from B to D. Okay, so let's find the midpoint. So remember, you add the two x's and divide by 2. You add the two y's and divide by 2. So from A to C, you're going to go 1 plus 1 and divide by 2. You're going to do 2 plus -4 and divide by 2. So that would be 2 over 2, which is 1. And this would be -2 over 2, which is -1. Okay, let's see if BD has the same midpoint. Okay, if they do, then you know you have a parallelogram, because all parallelograms have diagonals that bisect each other. And so where the midpoint is where it divides the segment into two equal segments. Okay, so let's look for the midpoint between B and D. So you do -2 plus 4. And divide by 2, and you do -1 minus 1. Divide by 2, and you get 2 over 2, which is 1. And you get -2 over 2, which is -1. Hey, look at this. The answer is yes. It is a parallelogram. So we've got to that first step. It's a parallelogram. We took one of those 5 steps to get there. The next thing we're going to do is say, okay, let's check to see if it's actually a rhombus. Do the diagonals meet at a right angle? Now, is this the only way to do it? And the answer is, of course not, okay? We could really do, let's see if I can scooch this over. We could do, is one pair of consecutive sides congruent? We could do the diagonal. No, we can't really see if they bisect opposite angles. That's kind of impossible on graphs. But are the diagonals perpendicular? Is a pretty fair way to go. Okay, we could do the distance formula on consecutive lengths. So we could be like, is the length from A to D congruent to the length from D to C? Okay, so just pick two sides in a row and find their distances and see, does that make sense? Okay, let's see if I can get out of here. Okay. No, I don't know if I can. Scooch her away. Here we go. Okay, so let's find the slopes of the diagonals and see, do they meet at right angles? So let's find the slope from A to C, that M equals, and then let's do from B to D and see what M equals, okay? So from A to C, we're going to do y minus y over x minus x. We have to be very careful with our order. So -4 minus 2 over 1 minus 1. And that's going to be -6 over 0. Oh, that's undefined. Okay. And then let's do from B to D. Okay. So from B to D, let's find the slope. Okay. What would be perpendicular to undefined? Undefined is directly vertical, isn't it? So directly horizontal, or a numerical value of 0, would be perpendicular. So are the diagonals perpendicular to each other to show, is it going to be a rhombus? So let's do -1 plus 1 over 4 plus 2, 4 minus the -2, so that'd be 0 over 6, or 0. Hey, look at this. Diagonals are perpendicular, so therefore it is a rhombus. Okay, so it starts with a parallelogram, that's true. Now we've moved to say, yes, it's also a rhombus, okay? And we're going to keep going until we get the most specific name, okay? So if the next answer is no, we would stop at rhombus, okay? If the next answer is yes, okay, let's go over to our sheet again. If it's a parallelogram and if it's also a rhombus and it's a rectangle, So if it's all three things, then that means that it is going to be a square. Okay, so we have to check to see. We know it's a rhombus. We know it's a parallelogram, so we might just stop there, but let's check to see, is it a rectangle? And if it's both a rhombus and a rectangle, it will be a square. Okay, the test for a rectangle is, are the diagonals congruent to each other? Okay, that's, you could check the slopes of two consecutive sides and see if they're perpendicular to each other, to see if they make a right angle, or you can check to see, are the diagonals congruent? So this one asks us to say, are the diagonals congruent? So let's try that. So let's check it out. Diagonals. So let's do from A to C, the length. So I'm not going to put a segment over it. So we're going to find the length from A to C. We're going to find the length from B to D and see, are the diagonals congruent? And if so, it's going to be a square. Okay. It'll be a rectangle, which means all three yeses. So that would be a square, but let's check it. So A to C. So the distance formula says take the x's and subtract them. So I'm going to do 1 minus 1 and square it. I'm going to subtract the y's of A and C. So it would be 2 plus 4 squared. So 0 squared and 6 squared. So that's the square root of 36 or 6. Okay, so that's the length of one diagonal. And then from B to D is going to be negative 2 minus 4 squared. And then negative 1 plus 1 squared. So that would be negative 6 squared, which is 36 plus 0 squared. So that, hey, that's the square root of 36. Who is 6? So guess what? That is a yes as well. The diagonals are congruent. So that means it is a rectangle. So what's that mean? That means our final answer is bing, bing, bing. Let's get this. This is going to be a square. Why? Because it passed the test of a parallelogram, passed the test of a rhombus, and it passed the test of a rectangle. So with its yes for all three, it's going to be a square. The diagonals are congruent, the diagonals are perpendicular, and the midpoint, the diagonals bisect each other. Okay, so that's kind of cool. And so this method is probably the fastest method to go. It's just focus on the diagonals. You have fewer math things to do. Okay, find the missing side measures and lengths of this. Okay, given a rhombus where JG is 8, okay, and JH is 15. Okay, can you find the missing side measures, okay, and the lengths of the diagonals? Well, we know that we're looking for this length over here. We know this meets at a right angle. So we could do 8 squared plus 15 squared equals x squared. Okay, this hypotenuse here. And so that would be 64 plus 225 equals x squared. And then if you add those up and then take their square root, you get 289. The square root of 289 is 17. So that means this length is 17 here. And so that means from F to H, the length is going to be 30. And that would be centimeters. And then from G to I think that is. My contacts were getting tired tonight. And we got 16 centimeters. And then from G to H is equal to 17 centimeters. Kind of cute. Okay, there we go. And then this one says, given a square, can you, in KO is going to be 12. Well, that means this is 12. That means this is 12. That means this is 12. Okay, how are we supposed to find the rest? Okay, let's think about this. Okay, well, we have a square, right? So that means this is a right angle here. That means this is 45 degrees because remember the big angles get bisected by the diagonals. And so this is 45. So we have a 45, 45, 90, don't we? This diagonal here is 24. And so if you think about this is x, and this longer side is x root 3, x root 2, pardon me. And so therefore, 24 is equal to x root 2. What am I doing? We want to make it smaller, okay? So let's divide by the square root of 2. So if you take 24 and divide it by the square root of 2 to get x, we have to rationalize it less times top and bottom by the square root of 2. You get 24 square root of 2 over 2, or 12 root 2. So each side is 12 root 2 centimeters. The diagonal is 24, okay? And that's about all we had to find, okay? So there we go. So remembering, hey, the ratios of 45, 45, 90s are x, x, and x root 2 for the hypotenuse. We knew the hypotenuse, so we just divided by the square root of 2 to get to the legs because we wanted to make it smaller. Okay, if you knew the legs, you times by the square root of 2 to get to the hypotenuse. So we got this. Thank you so much. Have a good day.